In example 3 here, we have the following. We have 1 minus cos squared theta equals cos squared theta tan squared theta. So in this case here, I'm just going to leave this left side alone, or I can actually change it right away. If I change this left side here, I can rewrite this as 1 minus cos squared theta using our Pythagorean identity is just sine squared theta, and I can do that change right away. My right side, I'm going to try to clean up. So this is the same thing as saying cos squared theta multiplied by, instead of tangent, I'm going to rewrite that as sine squared theta over cos squared theta. And here I have my cos and cos that will cancel out. So ultimately I'm left with sine squared theta there on the left is equal to a sine squared theta there on the right. So we have left side is equal to our right side. And there we go. This proof is completed. In example B here, let's see what we have. So example B, we have secants and cosecants here. So the first thing I want to do, again, just write everything in terms of sine, cos, or tangent. Well, no tangent, but sine or cos really. So secant I can rewrite as 1 over cos squared x. And all of that's divided by secant squared x minus 1. Well, that is one of our trig identities. That secant squared x minus 1 is the same thing as saying tangent squared x. Okay, and over here on the right side, I'm just going to change that cosecant into 1 over sine squared x. Okay, and again, I just did that one quick switch there, and that's okay. We can switch if we need to on both sides, but again, just one switch there. Here, I'm going to rewrite this. This is the same thing as saying 1 over cos squared x multiplied by, and tangent, of course, is sine over cos, but if you reciprocate it, this is now cos squared x over sine squared x, and that's equal to 1 over sine squared x. And again, here I see a cos squared x and a cos squared x that can cancel out because one numerator, one denominator. I'm left with 1 over sine squared x there on the left is equal to a 1 over sine squared x there on the right. So again, we have our left side equaling our right side, which completes this proof here in part B. Prove the following. Again, more proofs. Here we go, just a bit more complex. So this time I'm going to keep the right side. I'm going to keep cos x. That seems reasonable to try to match up to cos x. So what can we do here though? So for this first one here, I'm going to rewrite everything. So I see secant, that's the same thing as 1 over cos x. I see that sine x, so I'm going to rewrite that as just sine x. No change there, leaving a 1 there just to match up. Cotangent is the same thing as saying cos x divided by sine x. All of that is over our denominator of tangent over cosecant, and tangent again is just sine x over cos x. And cosecant, of course, is just, there should have been multiplication between all of these. Cosecant is just 1 over sine x. And again, all that we're hoping is we get cos x. So let's see if we can clean up a few things. Cos x denominator cancels out with cos x numerator. Sin x numerator cancels out with sin x denominator, leaving you with 1 overall up top there. Over here, sin x, cos x, leaving you with 1 over cos. So let's rewrite what we have. We have 1 in my numerator divided by 1 over cos x. And of course this here just simplifies down to cos x equals a cos x. So I can say my left side is equal to my right side on this proof here. On the next example, I don't really like that cotangent, so again, I write everything in terms of sine or cos. So on the right side here, right away, I'm going to say cotangent is the same thing as saying cos x over sine x. And now I want to match everything here on the left to that cos x over sine x. So let's start. Secant is the same thing as saying 1 over cos, but before I get there, I should try my best to combine my two fractions here because I only have a singular fraction over here on the right. Let's combine these on the left here. So this I can rewrite as secant x cos x minus sine x times another sine x. All of that is now being divided by sine x cos x. From here, let's see what we can do. This secant I can rewrite as 1 over cos x, and that's being multiplied by cos x, and that we have subtract of sine squared x because I combine sine and sine. All that's still being divided by sine x cos x, and we want to get to a cos x over a sine x. From here, my cos and cos, one numerator, one denominator, will cancel each other out, leaving me with just 1. So now I have 1 minus sine squared x. All that still being divided by the sine x cos x. And that's equal to cos x over sine x. And of course, again, taking a look at our Pythagorean identity, that's our numerator here. 1 minus sine squared x is part of Pythagorean identity. That's the same thing as saying just cos squared x in our numerator. All that's being divided by sine x cos x, which equals cos x over sine x. Last but not least, let's cancel a few things out. That 2 and cos x will cancel out because that means I had 2 coses up in the numerator there, so that's just going to cancel out, leaving me overall with cos x numerator, sine x denominator, and that does match up finally to our cos x sine x. So again, I can say to finish this off, left side here is equal to my right side over here. For example number 5, we have proved the following again. So, just a bit more complex. So again, cotangent, I don't really like cotangent. I'm going to rewrite cotangent in terms of sines and coses. Here, let's start with our double angle identity. I see this 1 here, and again for cosine I have 3 different options. I'm going to choose the option that's going to get rid of this 1. So right now I have 1 plus, and the only option that I can use to get rid of that is the middle option, which is 2 cos squared x minus 1. All that's divided by sine 2a or 2x there. Double angle for sine, we only have one option. This is the same thing as 2 sine x cos x. And that, of course, is all equal to cotangent, which again, I don't really like cotangent, so I'm going to rewrite that in terms of cos x over sine x. Okay, and from here, what can we do? Well, my 1 and 1 numerator will cancel out because I have positive 1, negative 1, that cancels out. I have 2 and 2, these two will cancel out, and I have cos squared x and cos x, so again, my squared and my cos will cancel out as well. What does that leave me with? That ultimately leaves me with cos x in my numerator, sine x in my denominator. And that does match up over here, so this is just cos x over sine x. So again, here, this proof is completed because our left side does equal our right side over here. This canceling step, by the way, you could have done in multiple steps, but I just noticed that things canceled out so nicely that I can do it in one step. Last but not least, we have example B here. So we have sine x plus cos squared x, or cos x all squared, all divided by sine double angle, equal 1 plus cosecant double angle. And this one here we really haven't ever touched or ever done, so let's rewrite a few things. So first off here, squared just means we're going to multiply out our numerator. So my numerator is going to be sine squared x, and we have plus 2 cos x sine x plus cos squared x. All that's going to be divided by our double angle identity, which is 2 sine x cos x. Okay, and sorry, those are x's. And here on the right side, I have 1 plus, this is going to be 1 over sine 2x. So here, what I have is the following. I can try to separate a few things. So first off, I'm going to rearrange. I'm going to write my sine squared x plus cos squared x together. And then I have this plus 2, and I'm going to quickly rewrite this as well. This is going to be 2 sine x cos x. So I just quickly did a quick flip because I can multiply in any order. And if I wanted to, I can take this apart in a addition statement. So putting them over common denominators. Common denominator here is just 2 sine x cos x. And over here, 2 sine x cos x. And of course, all of that is still equal to our right side, so that's 1 plus 1 over sine 2x. Okay, so what do we end up with here? Sine x, or sine squared x plus cos squared x here, that's Pythagorean identity. That's just 1 up top. 2 sine x cos x on the bottom there, that's the same thing as saying sine 2x, so double angle, plus this here would just cancel out as 1, and of course that's all equal to 1 plus 1 over sine 2x. And so there we go. Again, we have the left side matching up with the right side. And we are done. And that's the end of our lesson today. If you have any questions, please feel free and ask.